because we know the initial position, we know the initial velocity. These informations are in the description of the problem, okay?
Yeah.
We need only read again the problem and put the informations here. I will do a copy and I will look the situation here. So we have this information. This information is very important. The model, the absolute value of this velocity is 20 meters per second. But we can write this velocity in his components, okay? In the component x, in the component y, because we are trying write this problem in a parametric form, okay? In a y and x form. First, we need know the equation. The equation is here. It's only this. But now we can put the right values. But to this, you need just to know some math rules of angles, okay? Like sine and cosine. Did you know sine and cosine?
Yeah.
Perfect. You only need to know this, okay? Because here we have a right triangle. So you need to take the components of this triangle. If you think a little more, you will note this vector, this points vector here, is equal this, is equal of this vector. Why I am right here? Because it's more easy to see the triangle, right? So if this is the y vector, the component of the initial velocity in y-axis here is the same, because it's the same vector, it's the same range of this vector, okay? Here is the same thing, but in the x-axis. We know about triangles, about sine and cosine. If you remember, here we have a triangle. Okay, this is the hypotenuse. If the angle is here, this is the opposite catet. This is the adjacent catet. Okay, and we know rules of sine cosine. Sine cosine is the important here. The another functions, trigonometrical functions, is useless here. We just need sine and cosine. It's more easy. The math in physics is more easy.
Yeah.
Okay. You only need to note what is the opposite, what's the adjacent, just like that. For example, here we can note this vector is this side is the opposite of this angle. Because the y component is ever associated with sine, okay? And the x component is always, so you can memorize, is always associated with the cosine, okay? I will put the things here. I will write here sine theta is equal this velocity, the initial velocity and y, divided by the model of this vector. this information here, okay? 20. So I will put 20 here. And I will move. I will move this. Oh my God. I will move this to here. You are a smart guy, you know the another thing. Cosine is equal V0x divided by 22, because 20 is the hypotenuse of this situation. Okay? Do you understand everything?
Yeah.
Amazing. So we can obtain these values. We can obtain these values because I can, for example, multiply 20 in the another side of this equation. So I have 20 times sine of theta. But what's theta in our problem? Theta, I don't know what's theta, but I know sine of theta is 0.6, right?
Yeah.
I already know the value of sine. It's more easy yet. But how can I work with the cosine? In this situation, you need do some math. Use a rule, the most important theorem of the most important trigonometry theorem of the math is this: sine square plus cosine square is equals 1. Okay? If you know the sine, you can obtain the cosine, solving this equation, okay? I need the cosine because this. But first,
Yeah.
can you do this count for me? 20 times 0.6? I think it will be 12, but can you do this for me?
Um, 20 multiplied by 6,
Yeah.
0.6.
0? No. This number is 0.6, okay, or 0.6. 20 times 0.6.
It's 12.
12, okay. But you need say to me the unity of this problem. We are speaking about velocity, right? So this have a velocity unity, meters per second, right? You cannot forget this because the Portuguese teachers are very boring about these things, okay?
Yeah.
You need to remember. Amazing guy. So we need obtain the value of cosine, and we have this equation. This is a famous trigonometric formula. I will put this sine in the other side. So we have this, but cosine here is squared. So I need to do the square root here. And now we can do this math to me because I need to go to the bathroom. Okay, so do this count to me, and when I come back, you say to me the answer. Okay, the cosine answer. It is just a second. Okay, I go to the bathroom. I come back. Did you do this math, this count, this calculation?
Yeah, it is 0.632.
0.632. I don't know. I suppose you are wrong, okay? Because we have 1 minus 0.6 is 0.4, right?
Yeah.
So you need to think what number I need multiply by himself to take 0.4. I suppose is 0.2, I suppose, but I can be wrong. Just a second, I will do this count. 0.4. Yep, 0.4. Oh, you are right, I'm wrong. Amazing, amazing. This is new to me. Okay, we have the cosine of theta, but you can realize we don't know what's theta. We don't know the angle. Sorry, we don't know the angle. This is very cool because we know the sine, the cosine, but we don't know the theta. This situation will repeat in your exercise, in your proofs. So the first thing here is you need to be confident about the informations you have in the problems, okay? You don't need the angle. You need the relation of the sides of the vectors, okay? Just it.
Yeah.
Amazing. Because the big problem, the bigger problem is the students don't know if they have all the informations to do the exercise, but you ever have, okay? But sometimes you don't realize, you don't note, but here we have. So amazing. So we have cosine, you have sine, so we can, I don't know, we can take this, put here, and again, the axis, the x-axis is 20 times the value of the cosine, 0.63. Can you do this multiplication for me, please?
It equals 12.6.
12.6, okay. 12.6 meters per seconds, okay? Never forget the unity, because here we are doing physics. So if you need some help in math, I can help you too, okay? In some class, if you have problems in math, you can send to me the math exercise. I can help you, okay?
Okay.
Amazing. Let's continue this. So we have the velocities. We have the velocities here, but I need change these equations a little bit because this first equation is a y equation. So I will change the letter s to letter y, okay? Because I need show to you this is a y equation in y-axis. The acceleration in y-axis is the gravity. So I can change the letter here to g, okay? In Portugal, they name it this letter of G. G. So when they speak G, they will speaking about gravity. Okay.
Yeah.
Just tricks in Portuguese if you need. You are you doing Portuguese classes?
Yeah.
This is important. So,
Yeah.
in YouTube, you have a lot of videos of Portuguese teachers, but the most of the videos is Brazilians speaking. The Brazilian Portuguese is more easy than the Portugal Portuguese because the Portuguese is speaking really fast. Even even me, I don't know sometimes what the Portuguese are speaking. So it's very normal you don't understand too. Okay, it's very normal because Portuguese is speaking very fast, and they contract the letters and the syllables in the words a lot. It's very complicated to understand them. But okay, you are a smart guy. You will get this. So here you can realize, you can note, I changed the velocity too, because here is a axis, x equation in the axis x. Okay, the horizontal line in our graph. So here we have this velocity, this axis velocity. So now we have all the informations, but you probably are thinking about this. But this is a choose, is a choose. My choose is this values is 0, okay? Because here is the referential, of our graph. So I put 0 because it's more easy to do the math, okay? So here is 0. Y0 and X0 is the initial position. It's normal to put this equals 0, okay? It's not always, but in the most of the situations, this value is 0. Okay, I will copy this and put here again, and I will erase this and this because it's 0, right? I will erase these two, and I will change the values because we do the math to me. This is 12. The gravity is 10 meters by second square. But you need have attention here. Why? Because the gravity is acceleration to down, okay? Down in
Yeah.
our analysis is a negative situation because this velocity is positive. If my mass up, this is positive too, but the gravity is to down. So in this situation, the gravity is negative, but we have situations where the gravity is not negative. For example, situations where a body goes down off a building, for example. This situation is normal to put the gravity positive in this situation here, but in our situation, our bidimensional situation is more easy put the gravity negative. Okay, so here we have what? Okay, here is minus 10. And remember, the gravity is only in the y-axis, only. Because the only y-axis we have acceleration of gravity, because the gravity is a vertical force, not a horizontal force. And here we can put the velocity of x, the velocity in the x, you show to me 12.6. So, man, you need memorize a thing. You need memorize a thing. In x-axis, in the horizontal, the velocity never change, never. This you can memorize because we never have acceleration in this kind of problem, okay? The acceleration here, again, is only the gravity. So if we don't have acceleration in horizontal, the velocity is always the same. Is always this value here. Always. This is strange because we can show the body uh, uh, decrease the velocity, but this decreasing is only in y. It's only in the vertical, okay? In horizontal, no. Okay? Do you understand the situation?
Yeah.
Uh, very good. So, right. This is the answer of the first problem. The two parametric equations. Okay. You can write this in another form. Oh my God. You can write this like your teacher, um, um, like your teacher's likes. For example, your teacher put this. Um, put this A like with this thing, but I put it wrong. Sorry. Minus 10 divided by 2, 10 over 2 is 5, okay? So I will put 5 here. Amazing. And here, I will put this here. The another equation. This is another form to write the same thing. I write here. It's the same thing. It's just another form to write the same thing, okay? Your teacher will accept this and this, okay? It's the same thing. You need to understand why this is a parametrical form, because y and x is depends of the same parameter, the time. The time is a parameter here. Did you understand all the things I explained to you?
Yeah.
Okay, amazing. Let's go to the problem B. Write the Cartesian expressions of the position vector of the velocity 2 to time equals 1 second. The ball is upping or down in this instant. If we have the position equation, and we have the position equation here, this colorful equation here, we have only the position, but we don't know if the body is upping or down, up or down. We don't know. To know this, we need to know the velocity in this instant, okay? So we need the expressions of the instant velocity. In our last class, I speak to you, the velocity is the derivative of the position, okay? So to take the velocity of this body, you need derivate this, okay? You need derivate this equation, and after this equation, okay? Can you derivate these equations for me? I suppose you understand the derivatives in the last class. So can you try derivate this for me, please? You can take your notes of the another class and do this for me. When you do, just tell me the answer, okay?
Yeah. You want the derivative of what?
You need derivative this.
Of okay, y. Okay.
Yeah. The derivative of x is more easy, is easier, but your focus is in y. And you need to remember, I suppose, the rule, the potential rule. If your function is x to the power of n, the derivative is n x to the power of n minus 1, okay? This is the rule you need to use here. Just this rule.
Yeah. I sent you my answer.
Okay, let me see. Well, I am not understanding what you write here, but what is this? This is a letter T?
Yeah.
Yeah, but you need derivate this T too. What's the derivative of T in the situation? The
12
derivative of
minus
T is 1. Do you remember?
yeah, yeah.
So we can erase this, okay? And here, okay, is cool, but you can simplify this for me, right? You can, I don't know, could cut this
Yeah.
choose, okay? And you can subtract this in the exponential.
So it will
So it's
be
more
10,
easy, it's more beautiful if
10
you
t.
write this, okay? Problems? No, not. But it's not y. It's not y. It's the derivative of y. In this situation, the derivative of y is the velocity in y, okay? The velocity depends of the time, okay? So the velocity in this situation in y-axis have this formula. Now you can note if in this instant the mass is up or down, okay? You can just put this times the time 1 second in the equation you obtain. Okay? Do you understand?
Yeah.
It's very easy if you understand this. If the velocity is positive, the body is upping. If the velocity is negative, is down. I will put the 1 in the value of t, and we have 12 minus 10. So we have 2 meters per second. So the velocity in y-axis in this instant is positive. So the body is upping. Positive velocity, the body is upping. Just like that, very easy. Okay, this is the velocity. So I will put this sign because to you remember, the body is upping. But it's not only this the problem they want. They want the position the position in the instant t equals 1. So to obtain the position, you can just put the t equals 1 in these equations, okay? So when you put t equals 1 in these equations, say to me the answer, okay?
Yeah. So t is equal to 1.
Only this. Only put this in the equation, and you solve the math, and you can say to me the position, the y position, the x position too, okay?
Okay. I do it separately. So y in the y area.
The y position.
Okay, okay.
The y position. So first the y position. So first you put one here and one here, do the math, and say to me, okay?
Yeah. Y is 7.
7? Just 7? Yeah, I don't know. Let me see. I will try here. We can just put the 1 here. So 1 here, 1 here. So we have 12 minus 5. So it's 7. But 7 what? What's the unit of this value? Is, I don't know, seconds? Is years? Is kilometers? What is the unit here?
Meters.
Meters.
Oh.
Exactly. Amazing, man. So the last one is just the same thing, but in the axis. You put 1 here, so you have 12.6 meters. Okay? Very easy, very clean, man. Very good. So it's enough today. We have another class tomorrow, right?
Yeah.
Yeah. So see ya. Bye.
Okay. See you.
And thank you.